So these two problems here are the two problems from the group work number 6, where you figured out the A, B, and the C. So now let's go finish it off, because on the group work, you just had to find the numbers. So now I want to make sure you know how to take the integral of each of these. So I'm just going to rewrite these. So that's 10 times 1 over x minus 3, and then plus, and I'll just keep the negative here, x minus 2 over x minus 2, and then plus a negative 5 over x minus 2 squared dx. So you know this is an easy ln. So 10 times ln of x minus 3 plus, or minus actually, and then this is an easy ln also. Okay, now what do we do with this? This is not an ln, so it is necessary to do a u substitution. So du is dx. So if I pull this negative 5 on the outside, this gives me a negative u to the negative 2. And you know how to take the antiderivative. You add 1 to the exponent and put it over that same number. So this turns into a plus 5. And if I rewrote this as the fraction, I would get this. So then I would put the u back in. So I would get plus a 5 over an x minus 2 plus a c. And of course, these two parts carry along. I just neglected to write them each time, but you know that they're there, and that would be the answer. So I just want to make sure that you're not taking ln when there's a squared power. It has to be just like an x minus something, because I gave you that extra La Jolla theorem thing, integral of 1 over ax plus b is a 1 over a ln of ax plus b. And so that's just if there's a number in front of the x. In both of these cases, there's no number in front of the x. So that's why it's an easy ln. All right, so let's go to the next one. So the next one, this is me showing what to do after you find the a, b, and the c. So there's still some challenging parts to this problem after you find the a, b, and the c. So I'll refer you to the videos and the PDFs of group work number 6 so you can see how we found those. But now we go to finding the integral of this. So this integral is negative 2 over 5 ln of x minus 1. This, I'm going to take the time to write it as two separate fractions. So I'm going to say plus 7 over 5x over x squared plus 4. And not only am I writing it as two fractions, I'm going to write it as two integrals, plus negative 3 over 5x squared plus 4. Okay, so let's look at this integral here. Whoops, this integral here. You are so good at easy u substitution. You see that if I let u equal the denominator, du is this, 1/2 du is x dx, right? So then this 7/5 carries along, and I'd have a 1/2 and then a 1 over u du. And so then to finish this one off, I'd say I'd get a 7/10 ln of u, and u is x squared plus 4, right? So that would be the second term. So there's the first term, there's the second term. Let's go over here. What would that term turn out to be? So I can see I could pull this negative 3/5 outside. Wait a second. Do you recognize it? Isn't this arctangent with a squared equaling 4? So I'd carry the negative 3/5. And to take the antiderivative, you get a 1/2 inverse tangent of x over 2. And then you would just carry this negative 2 over 5 ln of x minus 1 plus that along. So that is the answer to number 2. So let's go and see what's happening in number 3. So number 3, and this is the challenge of integrals, of knowing what to do when. So you're recognizing this as a type 2 integration of by parts. So type 2 means when you let u equal the function you know the derivative of. So that would be ln of x plus 3. And then dv would be dx. So v is x, and du would be 1 over x plus 3 dx. Okay, save that for later. Okay, so let's put it together. So I have u, v, so this is x ln of x plus 3 minus the integral of v du. Okay, so many times, whoops, if I rewrite it, I can see things that are happening. So I'm just going to put this over here. And I'm going to say, you know what? How about if I put the x on the top? Because what would be really, really bad math is if I said x times 1 over x plus 3. So I'm just going to make sure you would never do this. So you would never say, oh, let's split it up around that addition. So x over x plus x over 3. Really bad math. You cannot separate around addition or subtraction in the denominator. So if I look at this, oh, this is way back to when I did in first section. So if I add 3 and subtract 3, okay, let's see what happens. So I'm going to carry all of this along, minus. So if I take this over this, x plus 3 over x plus 3, and then I have minus a 3 over x plus 3. So that's all in the integral. So again, I have to carry everything along. So minus, and inside the integral, I'm going super slow here to make sure I don't make any mistakes. That's 1. And this is minus 3 times 1 over x plus 3. Okay, let's finish off and do the antiderivative. So I'd have x ln of x plus 3 minus, I'm going to put the parentheses here, antiderivative of 1 is x. I'd carry the negative 3, and you know the antiderivative of that is ln, plus a c.